Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology. And everyone, welcome into the program. I hope that you are that you're doing well, running well. Yes, you're all computers. I'm very, very proud of you. You've made the leap. Good job, everyone. I hope that you're all doing well and you are ready for today's program. Because today on the show, we have, of course, the one, the only Mr. Ralph Bond. He'll be joining us here in just a moment as our science and technology trends correspondent. And you can guess from that kind of title that we are going to be talking about, trends and things and stories that may not have caught all the headlines, because the headlines have been gruesome, to say the least. This week has been a very strange week, but we are here to, bring you something a little bit different and better, we think. So with that being said, computeramerica.com, that's where you'll find everything, including past shows, future shows, show notes, articles, reviews, contests, giveaways, social media links, everything and anything that Computer America does, you can find it at computeramerica.com. And of course, we have a tag for Ralph, so if you want to find all of Ralph's stuff, hey, we make it very easy so that you can see past weeks, because I don't say this often enough, but what Ralph finds are often, kind of cutting edge things, like bleeding edge. And, a show from, I'm sure, 6 months ago is just as relevant today as it was 6 months ago, because it's research and, it's still very fun and exciting, and it's not really time sensitive. Like when we do the daily news headlines, often that kind of stuff, if you go back and listen to it 2 weeks later, it's like, oh, well, that's old news. Not so much with what Ralph does. So we really like that part of the show as well. So with all that preamble, let's go ahead, bring Ralph on and just have fun with it. So again, he is our science and technology trends correspondent, longtime contributor, and of course, hey, Ralph, welcome back onto the program. How you been?
Oh, I'm doing great, getting ready for Christmas with the 4 grandkids. It's pretty nuts. Finally got the house decorations all squared away. So, okay, we're ready.
Did you do the whole Griswold thing, or did you just go simple this year?
No simple. Not here.
Perfect. That's great. So
I'll send you a picture of the outside of the house sometime, and you can see how crazy.
Perfect.
It is.
It's Ralph. There's something about seeing. And don't get me wrong, technology has done amazing things. LEDs for Christmas have, really changed what Christmas could be, Ralph. But I don't know. Whenever I see someone with all the lasers and the inflatable toys and stuff like that in the yard, I'm like, it took maybe an hour. But when you see a traditionally lit home with the hung lights all over the, I don't know, the effort makes a lot of it. So,
Well, we fit that category, but very traditional. Perfect. My wife is very traditional when it comes to Christmas, so I will send you pictures of the outside of our house, and you'll see what I'm talking about. It takes me days,
but it's fun. It's fun. Anyway, I'm sure the grandkids love it.
It's great to be back, Ben. It's wonderful to be back. And you were talking a moment about the news cycle this week being strange. Of course, it's strange, scary, and frequently very depressing, folks. You're not going to get that here. You might get strange, but it's strange in terms of the wonders and amazements of science and technology. And what Ben and I do every Friday is highlight 4 recent articles that show us key trends and developments in all kinds of things: artificial intelligence, robotics, medical technology, sustainable energy technology, transportation advances, agricultural technology, space research, physics. Wow, you name it. And most important of all, as we just alluded to, we're going to give you an oasis of positive news thanks to the world of science and technology.
Absolutely. And I think story number 1 is going to fit that, in that this is something that I have not a lot of experience with. Don't get me wrong, we've talked to a lot of guests on the show about different ways to communicate and boost signal strength and so on and so forth. Story number 1, very much a research, but still I I guess this is, yeah, we'll talk about the applications later, but still very strange about a foldable, I guess, antenna or like a blanket-like antenna. This is strange.
There's a lot of things going on with this first story. By the way, it comes from an outfit called Electronics for You, just the letter U. So electronicsforyou.com. Interesting little website I just stumbled on this past week. A headline here is Columbia University engineers knit a blanket of sophisticated radio frequency antennas. So there's a lot going on in this story. This has to do, some of the elements here are, there's a big push for wearable or flexible communications technology, and this fits that category. So we'll dive into this in the show notes. Folks, come out to computeramerica.com. Get today's show notes. The show notes include links, pictures, and additional information, side notes that I inject into these articles. Again, I don't write or compose these articles. I find them and I distill them, and then Ben and I just give you the highlights. So with that said, let's jump into this story. So researchers at Columbia University are the first to use traditional flat knitting fabric techniques to fabricate flexible, lightweight metasurfaces, in specific to create large aperture antennas that can easily be stowed and deployed for long-range communications. Now, I know that's a lot to take in one sentence, but we'll try to explain. A little side note I injected. I said to myself, metasurfaces? What's that? So metasurfaces are artificial, ultra-thin surfaces engineered to control light and other electromagnetic waves in ways that natural materials can't. And in the show notes, you can learn more if you want. I also have a little injection in the show notes about what are large aperture antennas. You can get into the show notes and learn more there too if you want to. So a team of researchers from Columbia University Engineering Department has developed an innovation in radio frequency communications by embedding antennas directly into textiles using a flat knitting process. And this innovative approach could make communication systems lighter, more portable, and easier to deploy, especially in remote locations or emergency situations. So, Ben, I'm sure your brain is already spinning like mine on all the possible applications for this.
Yeah, and for those who are watching the video, appreciate you. But also, like you can see here, and for everyone who's just listening, Ralph, like when you think of antenna, maybe a lot of people immediately go to like direct TV or satellite TV, and they have the antenna on the roof, the big round thing.
Whip antennas.
Yeah, and so many antennas of the past are just these big metal things, and when you look at especially the Columbia Engineering page right there on the right there on the front, Ralph, like it looks like a nice cozy blanket, but that's your antenna. That's so cool.
Yes. And in the show notes, by flat knitting, believe me, I know nothing about all of this subject. In the show notes, if you want to find out what they mean by flat knitting, there's an optional insert there in the show notes. You can learn about that. You can geek out in the knitting world there for a second if you want to. So what the researchers did is they harnessed or used the concept of metasurfaces, which again are ultra-thin materials that control light and electromagnetic waves. And they use this to create flexible, lightweight, fabric-based radio frequency antennas, as we've been setting the stage for here. And their work addresses the challenges of traditional radio frequency antennas, which, to your point just a second ago, Ben, which are often heavy, rigid, and expensive to manufacture. So while textile-based antennas have used methods like let me back up for a second. Let me better set the stage for this. What the author of the article does here is say, this isn't the first textile-based antenna. It's not the first one in the world. It's just made very differently. So he says here, while traditional textile-based antennas have used methods like screen printing or even embroidery to add conductive materials to fabrics, these techniques have faced issues such as delamination and limited scalability. So that was the problem. That was what the researchers at Columbia University said to themselves is, fabric antennas, that's a great idea, but the current technology has limitations and problems. How can we overcome it? Answer, knitting.
Yeah,
so that's the thing that's so much fun.
Yeah, it seems like, and I just had to Google screen printing, I guess, this process where you kind of press the image onto a material, which is the delamination part, and then the other one is embroidery, which makes sense, but it takes a lot of time to embroider essentially an antenna onto this thing. So yeah, it makes sense.
Yeah. So with all that in mind, in contrast, the Columbia University team used a knitting technique called float jacquard knitting. Lord, I have no idea, but I did embed a link so you can learn about that. So they use this float jacquard knitting, traditionally used in patterned garments like Fair Isle sweaters. I have a link. You can see what those are. And the minute you see those sweaters, you go, oh, I've seen those Christmas sweaters and that kind of stuff all my life. But this method of knitting involves weaving 2 or more types of yarns to form a pattern, allowing for the direct integration of antennas during fabric manufacturing. That's the ding, ding, ding of this innovation for fabric antennas that these folks have come up with. And the team demonstrated the practicality of this technique by creating 2 prototype radio frequency devices, a Metasurface lens and a vortex beam generating antenna. And that's just, another couple of things that I've embedded links to so you can learn what the heck these are. And both were produced using commercial knitting machinery using metallic and dielectric yarns. Wow. So they're using commercial existing machinery. They're not having to invent new machines to make these fabric antennas. That's kind of cool. And a quick reminder, dielectrics are materials that don't conduct electricity but can store and manage electric energy, in a field. So remarkably, each prototype the team came up with was knitted in under an hour and withstood multiple washes and stretches without damage. The resulting textile antennas showed promising performance and could focus or shape radio frequency signals for communications tasks. Now, the bottom line, the article kind of wraps it up. It says, this promises lighter, more portable communication systems for remote or emergency use, opening the door to flexible, here's the key terms, wearable technology with powerful radio frequency capabilities. So they were able to create these large antennas on the space of the fabric, which just improves their ability to focus signals and or transmit. And so again, think about wearable technology. Think about emergency people wearing their antennas or covering surfaces with this flexible material. On and on, Ben. I just think this one's really great in the field of communications.
Yeah, and flexibility has the added benefit. I think a lot of people know this about their phone screens. You add a little bit of flexibility and you increase durability. So, we don't have these big things that can be cracked. No, these things can flex and bend and be, a little bit better off in those emergency situations. So, very, very cool. I mean, hey, Ralph, maybe that one day things like this would be part of your, your hurricane first aid, survival kit out there where, hey, you can just pull out a radio antenna and, have it plug into something else. This is very, very cool. And, obviously the science is there, but at the end of the day, it's a nice new durable antenna, and the applications, like you're saying, go, I'm sure even further than what we have thought of. So very, very cool. And
yeah, it's cool stuff.
And the video has a lot of the science in it. There, you can see it there, but you can check that out. That's in the show notes as well. So story number 1, story number 2, let's go ahead and jump on over. And we've heard this claim before, which, it's not like the other claims didn't do it as well, but in certain places, Ralph, you just need water, and, especially in places that don't have a lot of it. You need, some of those emergency situations. So check this out. This is another way to pull water out of thin air, and we are on a metamaterial kick, or at least, a new material kick. So let's talk about story number 2.
Yes, so far that's true. This next story comes from SciTechDaily, and the headline here, revolutionary new material harvests water from thin air, and here's the key, folks, without energy. So we've talked over the last several years, Ben, here and there, stories about all kinds of technology that does this process. Take the moisture that's in the air, even in the desert, there's moisture in the air, extract it and get it to create liquid water, so to speak, so you could drink or harvest for crops or whatever you want to do. Here's the key with this innovation. Without energy, all the other systems we've talked about in the past need solar panels to have energy to drive a system that'll do this process. No energy needed. That's the key. And you're going to learn about something called Janus, Janus crystals, developed by international researchers. This was a collaborative team, efficiently harvest atmospheric water without energy. And they were inspired by desert organisms, offering a promising solution to global water scarcity. So this story just hits it on so many levels. I couldn't resist. This is wonderful. So let's get into it here. A team of scientists from Jilin, I hope I'm saying that right, Jilin, Jilin University, NYU Abu Dhabi's Smart Materials Lab, and the Center for Smart Engineering Materials, this team has developed a new crystalline material that can harvest water from fog or moisture in the air without any energy input, unlike traditional energy-intensive desalination processes that you and I, Ben, have talked about before. And these novel smart crystals, named Janus crystals, are inspired by desert plants and animals which can survive in arid conditions. This was interesting. I kind of knew about this in the past, but I needed this refresher. For instance, desert beetles and lizards have evolved to develop surface structures that have both hydrophilic and hydrophobic areas that effectively capture moisture from the air. And water is attracted to the hydrophilic areas, and droplets are accumulated and transported through the hydrophobic areas. Now, if you want to geek out on what hydrophilic and hydrophobic means, I have an optional side notes here that define all this and give you even the Greek words that they come from. It's all fun to read. You can check that out. But basically, it's the idea of something that can capture the water and then transport the water into the creature, the plant, or the lizard, in this case, or beetles. Really amazing stuff. So what the researchers did is they chose 3 chemically versatile organic compounds from which they grew elastic organic crystals. Now, I apologize. This is very geeky stuff, folks. They then tested how each of these materials interacted with the airborne water, which led to the creation of the new water-collecting materials, which the researchers called Janus crystals, that contain both hydrophilic, that means things that will attract water, and hydrophobic regions, things that will reject the water, on the single same surface, just like the beetles, lizards, and some of the desert plants do. And one to capture water and the other to transfer it, to a receptacle for collection. So that's the scheme here. Pretty clever, huh, Ben?
Yeah, no, we have seen time and time again that looking at nature and letting nature guide technology. Nature has come up with some very innovative and ingenious ways to do things, and technology can learn a lot from it. Makes a lot of sense.
Yeah, it's very clever. So the Janus crystals that these folks have created capture humidity from humid air with the highest to date water collection efficiency. And again, this can work in the desert too. It doesn't have to be in tropical humid areas. And the crystals' narrow and light translucent structures enable researchers to monitor the collection and condensation of fog droplets or moisture in the air in real time by using light. No external power needed. Here's the key advantage over traditional desalination. This new process of condensation of aerial humidity, or fog, if you will, utilized by the Janus crystals, is spontaneous under ambient conditions and can be performed without the input of energy, potentially providing an endless source of clean water. So, wow, just another contribution to the effort to create water out of thin air, and this time without energy. Pretty cool.
Yeah, the image, I was trying to see if they had like some kind of like video or it in action. This is obviously something that they, either drew up or did something. I don't think it's like gushing water out of thin air into this container. But, just a little something. And Ralph, I'm instantly reminded of the they created these giant like ice pillars in the middle of a desert by pumping water up from the ground, and then they use like some kind of electricity to freeze the ice, and it created these giant ice pillars that, and like the biodiversity that kind of sprung forth, it did so much for the local ecosystem. Wow. Just little changes, and this one being completely energy self-sufficient, or non-dependent on energy. You can make a lot of change in a very short amount of time with technology like this. So
very cool. And
it's exciting.
And this technology, of course, in the photograph that you're showing on the video, folks, and again, come out to show notes so you can get the picture, is a small little device, if you want to call it that. Imagine scaling this up to a huge magnitude, and then the collection of water would be significant.
Right. Yeah. And I'm sure that a lot of villages would love something like this. So there you go. Story number one, or I'm sorry, story number two. Story number three, we're going to go ahead and jump on down. This has to do with, it is Friday. Why not talk about spirits and bourbon? Ralph, we don't talk enough about bourbon. So
yes, that's right.
As always, some of the biggest innovations aren't about creating something new. It's about doing something with trash, with garbage, with stuff that we would consider waste, and then turning that into a useful product. There's a lot to gain from doing something like that. And I think the bourbon industry, as per story number three, might have something to do with it.
This one is fun and really another light bulb, boom, of a great idea. This comes from an announcement from the University of Kentucky. And the headline for their announcement is Turning Waste into Fuel. Bourbon industry, whiskey, offers new path for renewable energy. Again, University of Kentucky. Great, fun story. So here we go. University of Kentucky, Martin Gatton College of Agriculture, Food and Environment researchers are turning one of the state's largest and fastest growing industries into an unlikely renewable energy source. So they're talking about the growth of their whiskey production in Kentucky, bourbon and whiskey, so forth. In a study published in the Journal of Environmental Management, the University of Kentucky team discovered that stillage, that's spelled stillage, stillage, which is the leftover byproduct from bourbon and whiskey production, holds the potential to be a sustainable energy supply. Wow. Stillage, which remains after grains are distilled into bourbon, has traditionally been used as feed for livestock. Okay.
So not a complete waste.
Yeah. That's pretty cool, Ben. Yeah, go ahead, Ben. And
I just said that feed for livestock isn't exactly useless, but I guess not the most efficient thing. So.
Well, yeah. So the feed for livestock for decades and decades, this was a great equation. You're making your bourbon, you have the stillage, this leftover byproduct of the process, which can be consumed by the cattle. Win, 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 right? Mm-hmm. But the article points out what's happening. However, Kentucky's cattle population has reached its lowest point since 1962, while bourbon production is expected to double in the next 5 years. You see the problem here? So this imbalance has prompted distilleries to seek alternative ways to manage increasing stillage. What do we do with this byproduct? This is where anaerobic digestion, a process that transforms organic material into renewable natural gas by using microorganisms in an environment without oxygen. This is where this technology plays a role in what the University of Kentucky team came up with. The team's research analyzed how the composition of bourbon stillage, affected by different grains used in production, impacts the amount of renewable natural gas they can generate. Whiskey and bourbon production involves a variety of what they call mash bills, B-I-L-L-S, and bills refers to a grain combination such as corn, rye, barley, and wheat. So they looked at this variety of these components, and the researchers found that these differences in the mash bills alter the biogas output during anaerobic digestion. This discovery provides distilleries with critical insights into how their byproducts can be efficiently turned into energy, with each type of mash bill producing different methane and carbon dioxide levels. Wow. And
Well,
some large distilleries are
yeah.
leading the way by incorporating anaerobic digesters to convert their stillage into renewable natural gas. Pretty cool stuff, huh?
It makes sense because I was just thinking that, unless every bourbon company has one recipe, and they're outputting all the same stillage, you're not going to be able to, create the same type of gas. Like, you're not going to have that standardization of gas that we have, at the gas station. But yeah, to be able to, I guess, come up with different types of it and utilize all different types that you kind of come up with, that, that's good. That's cool.
It is pretty cool. And to your point, there may be variances in the kind of qualities of the gas produced based on the differences in the stillage from distillery to distillery to distillery, if I could say that 3 times in a row. So here's the key benefit, though. The distilleries in question can use the gas for their own operations on site, reducing their reliance on external energy and lowering waste disposal costs. And the University of Kentucky researchers also noted that the gas can be used in multiple ways, including fueling trucks, heating homes, or generating electricity. And this creates a valuable opportunity for distilleries to cut energy costs and become more self-sufficient. So very clever. I just love the idea of, hey, fewer cattle. What do we do with the stillage? And the University of Kentucky researchers go, how about this idea? And I just love it.
Yep. And as I was saying from the outset, turning waste into something useful is, I think, the thing that's going to push humanity forward, time and time again, just turning this useless stuff into very, very useful stuff. So very cool for them.
Yes, extremely.
Yep. So number 4, and we'll go ahead and jump on over here. Not medical. I'm shocked at you, Ralph. What happened?
Well, it kind of sort of is with the implications for wheelchair design. So I kind of squeezed it in that way.
All right, that works. That works. So, hey, maybe coming to a wheelchair near you. And, Ralph, we have seen some crazy wheel designs. One of my favorite comes from NASA, and, they have different designs for, like, their rovers that go on Mars and stuff. I love the wheel designs that, they're trying to fit for cars, because one of the biggest wastes that we have, speaking of waste, is those old rubber tires, and turning those into useful products is also a thing. Right. But Ralph, like, tires are, there's a lot of development for something that has been invented, checking my watch, about 80, 100, 200,000 years ago, whenever the wheel was invented. Technology blazes forward. And this one, ladies and gentlemen, if you can see the video, I'm going to put up the video if you can see the image. Rob, it looks like cheese, but I'm sure it's not made of cheese.
Yeah,
so let's talk about story number 4.
A cheese wheel.
Exactly. So story number 4.
This is a good one. And usually what Ben was alluding to is normally the 4th story every week for us on Friday is something that's medical, technology related. And so this one kind of squeezes around the edges of that relative to helping people who are in wheelchairs. So not strictly medical. But anyway, it's a great story. I couldn't resist it. The headline here is this morphing wheel from South Korea could transform lives and robots. And this comes from a great website called wonderfulengineering.com. And if you have the show notes, and please, again, if you're listening to us as a podcast, I can't stress this enough. Come out to computeramerica.com. Get today's show notes. We'll have links, pictures, links to the videos, all this good stuff. You can dive in and learn more. And you can see what we're talking about. So, with that said, South Korea's Korea Institute of Machinery and Materials is pioneering a new morphing wheel that could revolutionize mobility for people and robotics. Imagine a wheelchair equipped with wheels flexible enough to handle obstacles like curbs, humps, and even staircases. Now, I want to stop for a second here, and Ben, you were kind of referencing this as well. There's been a lot of work, NASA, the tire industry, all looking at airless tires, flexible tires, all kinds of research going into rethinking, reinventing, if you will, the wheel.
Yeah.
So that's not new. The Koreans, though, have come up with something here that I think is particularly exciting and really cool. So the author of the article goes on to say, or imagine or envision an unmanned delivery vehicle taking the stairs to deliver food and groceries to your doorstep. But the key application in my mind is for wheelchairs. This is the vision for the morphing wheel, capable of overcoming obstacles up to 1.3 times the height of the wheel's radius. Let that sink in. That's just astonishing. And here's something that you need to get into the show notes, read deeper into the articles to understand what I'm about to say that the author talks about. He says, inspired by the surface tension of water droplets. What? Wow. This innovative wheel changes its form from solid to fluid in a way as it encounters obstructions, adapting dynamically to its environment. The morphing wheel could also benefit robotics in challenging terrains, including surveillance or combat robots on the battlefield, where maneuverability, of course, is crucial. Additionally, the Korea Institute of Machinery and Materials team hopes to use morphing wheels on 2- and 4-legged robots. I love that video you're showing right now. It really makes the point.
Yeah.
Improving stability and payload management in industrial settings where smooth movement is essential. The team's principal researcher explains that unlike other wheels, such as non-pneumatic or airless tires that we mentioned earlier, the morphing wheel's flexibility is enhanced with obstacle handling capabilities. Okay, now here's how it works. Built with an outer hoop of chain links and spoke wires extending through the hub, the wheel's stiffness is automatically adjusted by sensors based on the terrain. Wow. Pretty cool.
So it's not just an over-engineered bike tire. Like there's actual like mechanisms in there, kind of pulling and pushing and doing something.
Yeah.
Okay.
Yeah, and responding dynamically on the fly to whatever kind of bump or curb or whatever it encounters. In a recent demonstration, a prototype wheelchair, this is why I like this story so much. It's really, for me, the wheelchair thing I think is outstanding. A prototype wheelchair with morphing wheels successfully climbed stairs with 18-centimeter high steps while carrying a life-size dummy. And when they say life-size dummy, one with the weight of a human being of the size of the dummy. And the morphing wheel can currently reach speeds of 30 kilometers per hour. That's about 19 miles per hour. And the researchers hope to make it viable at car speed someday. That's up to 100 kilometers per hour. That's about 60 miles per hour. So they've got a vision for the application of this that could potentially even be viable for vehicles on the road. Isn't that something?
Yeah,
I just love this story. I just think it's so cool and so profound.
No, it's super cool, and seeing the video and seeing it kind of morph and do stuff like that. Like this is again not a story about suspension, because you can kind of see the wheelchair. It would be a bumpy ride, but hitting a rock or hitting something that a traditional wheelchair, if you hit any kind of like, let's say even like a threshold of a door, you can have issues with that. This, you would not have issues with thresholds of doors. Like even that alone would, I think, be a quality of life improvement for wheelchairs. So
yeah.
Very, very cool.
Yeah, pretty cool.
I like that a lot. So everyone out there, if you want to find out more, computeramerica.com, show notes, stories 1 through 4. And if you have been following along, you may notice there are even more stories. And these, though, Ralph puts together because the stories, we pick for time's sake, and that doesn't mean that there's only 4 good stories of the day. We haven't just picked that number because everything else is sad and depressing, and 4 is the most that we can get out every week. No, these other stories are just as good, but we just don't have time for them. So Ralph, let's at least give the nice folks the headlines, and then of course you have put links in the show notes if they want to find out more. So honorable mentions.
Yeah, we have 4 honorable mentions, which is our usual pattern. And the first one comes from newatlas.com. Largest all-electric aircraft in history will take off in 2025, next year. So we're talking about something that's not available right now, but it's a preview. Check it out. It's really
2025
impressive.
is a month away. So
there you go. Yeah. So this is pretty impressive. So check that out. The next one comes from phys.org, short for physics.org. Scientists identify crucial detail essential for the production of hydrogen from algae enzymes. So there's the whole world of producing hydrogen from algae that you and I have talked about. We've done many stories. These folks have identified a crucial detail that will help with the production of hydrogen from algae enzymes. Check that one out. It's a really great story. The next one, sciencealert.com. This is so humorous. Headline, we finally know what creates static electricity after thousands of years. You'll find out it has to do with the differentials of the two items rubbing against each other, but there's more geeky stuff here. We've got the links, everything, of course, in the show notes. You can learn more about this. I just think it's fascinating and kind of fun to think that only until recently did we, as scientists, we've understand this.
We've known about it, as per your article, we've known about it for almost 3,000 years, but didn't know exactly what caused it. So very cool.
It's pretty cool. And our last one comes from futurism.com, another wonderful website. Headline, scientists invent, this is funny, Ben. We'll leave you laughing. Scientists invent giant dishwashing machine for entire human bodies. So if you're really lazy, you can jump into this thing that looks like a capsule, lower the hood, and just lay down and be showered.
Ralph, I'm not saying that I wouldn't use it, but I'm also not saying I'm not looking for a buy link. I don't know.
Yeah, you know what? And this is coming out of Japan, and they're obsessed with cleanliness, and that's wonderful. I just thought of something serious, though. And it just now occurred to me, what if you're disabled? What if you're an elderly person that has to be physically put into the tub? This could be a way to get some cleaning in a very easy way.
Absolutely. Just throw them in the machine, hit the button, walk away, come back, and then you remember, for the 18th time, I forgot to load the jet dry, so now they're all spotty. Who knows? Everyone, thank you for tuning into the program. This is a lot of fun. Ralph, great stories as always. And ladies and gentlemen, if you want to find out more, computeramerica.com. That's where you'll find everything. And of course, Ralph joins us every single Friday to do these stories, and we really appreciate it. Ladies and gentlemen, until next time, thank you so much. Catch you here. Bye, everyone.